Hi, everyone. As many of you requested for this week, we are going to do our final project presentation as a recorded session. Many of you declared that you find this more helpful, basically following a recorded lecture. So today we are going to go through one of the typical assignments that will come up in the final project. The final project will be very similar to the midterm, and it is going to consist of multiple assignments. This assignment that we're going to do right now will be one of those assignments. So a typical assignment you will find in the final project will be something like this. Do countries with a high GDP per capita also have a high life expectancy? Basically, the question is, do richer countries live longer? Because you would expect if a country has a high GDP per capita, meaning the median income for that country is high, you would also expect them to spend a lot on healthcare, nutrition, which is why you would expect them to have a high life expectancy. Life expectancy means the average amount of time we expect people to live in that country for. Please produce a data analysis for this question using World Development Indicators. So there will be assignments in the final that will use World Development Indicators. There will be SIPRI, Stockholm Institute of Peace Research. There will also be FAO, United Nations Food and Agriculture Organization. This is going to be an exercise for World Development Indicators. So it asks, download data for GDP per capita in US dollars, in current US dollars, and life expectancy at birth, total years. So the first thing we do is that we go to World Development Indicators of the World Bank, and we are basically going to choose World Development Indicators, which is the default choice. And in the country section, we are going to select all countries. But remember, there are two tabs here. One contains the actual countries. The other contains the aggregates, the combinations of countries. So Caribbean small states, Arab world, Central Europe, and the Baltics. We are not going to select this. We are only going to select the countries. So you should have 217 countries. We select them all. I am doing this fast because this is already a recorded session. You can stop and go back at any time you want. The series are the variables that we're looking for. So make sure that you're downloading the correct variables. So here, the question asks me to download GDP per capita in current US dollars. So when I go and search for GDP per capita in the series section, it gives me a bunch of variables that are related to GDP per capita. So I'm going to just download and find the GDP section. This is alphabetical, so GDP per capita, not constant 2015. GDP per capita constant local currency unit. I don't want that. I want GDP per capita in current US dollars, which is this, GDP per capita, current US dollars. So I'm going to select this. The second variable is life expectancy at birth, total years. So I'm going to search for this as well, life expectancy. expectancy and search. Life expectancy at birth, female, male, and total. So what I want is life expectancy at birth, total. So I'm going to select this one. Again, I'm making sure that I selected the correct variables: GDP per capita in current US, life expectancy at birth, total. Yes. So when I click on this section, this selected part, it gives me the list of which variables I have selected. So GDP per capita, current US dollars, life expectancy at birth, total years. Now, time-wise, I'm going to require all years from 1960 all the way up to 2022. And when I selected everything, I'm going to do apply changes. And I'm going to go to download options. Don't make the same mistake that many of you did in the first project. Do not download Excel file, because then it's going to slow down your computer and cause a lot of crashes. Download the CSV file because it's faster to work with. Now, I am opening this file, and I'm not going to open the metadata. I'm going to open the data CSV. And it is going to bring the file. And because this is a CSV file, the best thing to do is just save it as it is. So you would be saving this as IR202, your last name, final project. There will be multiple sections, so this will be perhaps section A, and we're going to save this as Excel workbook. And it's important to save this right away, because if your computer crashes during the final project, you can also turn on the autosave option. You can update this as maybe Excel SX in order to be able to save this in automatic fashion. Turn on, yes. So it's usually a good idea to open the autosave function. If not, some computers don't have the autosave function. In that scenario, just save very frequently. Your save button is here. So saving this very frequently is a good idea, because everything can crash. It's normal, you know, Excel, your computer. So in order not to lose any of your work, just save this as frequently as possible. So I am going to parse this now, selecting the first row, X the columns, delimited, not tab. This is comma, separated. We go next. We go to advanced. We are going to select the point decimal separator. And I'm not going to choose any thousand separator. It's empty. And I'm going to do finish. Now here, you would remember that in the first project, we cleaned this data by concatenating, you know, Bahamas and, you know, Congo. You know, there's a cell shift problem in this, in most World Bank indicators. The first part of a country's name is parsed wrongly into the second column, whereas its first name is in the first column. So in the first project, we concatenated, we merged these two values and moved them into the first column. This time, we are going to combine multiple country names together, which is why we are just going to delete this section. So instead of the Bahamas, I'm going to delete this section and move this part all the way to the second column and just delete the here. I'm doing this because I'm going to combine multiple country names together, and I'm going to produce a map out of this. So I only need the Bahamas here. So I'm selecting the in both cases. The first values for Bahamas is GDP per capita values. The second values are for life expectancy for Bahamas. So I'm just going to select these two parts. I'm going to select delete, and I'm going to shift cells left. So I'm going to shift all this row towards the left, not shift cells up, not entire row, not entire column. We have to shift cells left. So when I do that, you're going to notice that country codes are now proper. You have to see that the series name and series codes have all have to be in the same column. There shouldn't be any cell shift errors. Let's scroll further down. The same thing is for Congo. So instead of Democratic Republic, we are going to just delete all these sections. But in order to differentiate between South Congo and North Congo, we have to say Democratic Republic of Congo. We can copy this and paste it here. Delete these Democratic Republic sections. I'm doing this fast because this is recorded. You can just go back and slow down whenever you want. And here we just say Republic of Congo, because these are two different countries. They're not the same country. Delete, shift cells left. I'm searching for other discrepancies in this data. Egypt is the same, Arab Republic of Egypt. I just need the name Egypt here. Moving further down, Gambia is the same problem. I'm going to delete the and shift cells left. Further down, Hong Kong, region of China. So what I need to do here is that I only want the Hong Kong region. So I'm deleting the China part here, shifting cells to the left. Islamic Republic of Iran. I just need the Iran part. I'm going to delete the Islamic Republic of. So as you can see, if I don't do this, the 1960 values are going to contain variable codes, which is bad. So in this context, 1961 values are going to contain 1960 values, and every single year will be shifted in such a way that at the end of the database, my 2022 values are going to be shifted like this into the empty year. So there's going to be error in the data, and there's going to be an error in the maps that I'm going to produce, the values that I'm going to produce. So Democratic Republic of Korea and Republic of Korea in this context are also different countries. Democratic Republic PRK is North Korea, so I have to just say North Korea, copy and paste this maybe, or you can do this manually. Delete, cell shift, and Republic of Korea is South Korea. I'm going to delete the Republic section here. So North Korea, South Korea, more. Macau is a part of China as well, so I'm going to delete China. Macau is an autonomous region. Federal states of Micronesia. I'm going to delete these as well. So this is called data cleaning. I'm preparing data for analysis. Data cleaning is the most important part of any data analysis workflow. And finally, Republic of Yemen. We delete this as well. Venezuela, Bolivarian Republic of Venezuela. So RB, I'm going to remove these as well. Fine. So now I'm checking if I have anything other than numbers in 1960 values. I'm correcting them if there is no. These all contain numbers and numbers and numbers. Let's see. We have to be precise. Okay, 1960 values all contain proper values and numbers. So as you would notice, every country has two variables. So Afghanistan, Albania, Algeria, they have GDP per capita values. They also have life expectancy values. So in order to work with both variables in different ways, I'm going to divide this data set into two. So here, I'm going to open up a new sheet, and I'm going to call this GDP data. And I'm going to create another sheet, and I'm going to rename this as life expectancy data. Now, what I'm going to do is that I'm going to select everything. You can also select everything by clicking on this corner. And even before maybe doing that, I'm going to select the first row, country name, country code, series code. I am going to copy this section, and I'm going to paste this into the first row of both GDP data and life expectancy data, because I'm going to need this first row for both. Now, I'm going to select this all. Then I'm going to go home. I am going to format this as table. What I need to do here is that I need the first row, I need the first row sortable. A sortable first row will contain this different color here. So this is sortable, this is sortable. So I'm going to, let's say, click on this orange. It says, where's the data for your table? Let's see if data is properly selected. Let's select the whole data again from the bottom all the way to the end of my data set. I'm just selecting all variables, all columns that contain a value. So 2022 variables are not here, so they're empty, which is okay. My table has headers because the first row are year values. When I click on OK, it's going to convert this into a table. And how do I separate GDP data and life expectancy data? I do this by sorting and ordering the series name column. So I'm going to sort this. I'm going to sort this by clicking on this sort button here. On your computer, this might look a little bit different. It's okay. Different Excel versions do this differently, but the function is all there. So I am going to order this part by descending name values. So I'm going to click on this. Now, what has happened is that it has sorted the series name based on the first letter. So I separated country values based on their life expectancy at birth with their GDP per capita. So their life expectancy at birth is in the first half of this data set. And you're going to notice that GDP per capita data are listed in the second half of this data set. So first thing I'm going to do is that the last value is Zimbabwe. So I'm going to select Zimbabwe and above for 2022 until 2022 for all values. I'm selecting the first half of this data set. Maybe not select the first rows. So I'm going to start over again, beginning with 2022 variables. I'm not selecting the first row, the header row. So from Afghanistan all the way down to the last value of life expectancy at birth, and that is Zimbabwe. So let me check if I selected the correct section. Not the first row, only beginning with Afghanistan all the way to Zimbabwe, and all year values, including 2022. I am right-clicking on any parts of this. I'm going to copy this. This is life expectancy at birth, so we're going to paste this into life expectancy data. Now, be careful where you are pasting this. It should start immediately in A2. So I'm going to click on A2. I'm going to paste the entire thing. And I have done correctly. So all values, all years for all countries. So this is my life expectancy data. Let's do the same thing for GDP data. So it starts with Afghanistan, GDP per capita. I am going to select all the way until 2022. And I am selecting all the way down till here. So it's on all the way down to Zimbabwe. I'm right-clicking on this, choosing copy. Now, since this is GDP per capita, this goes to GDP data tab. Again, be very careful where you are pasting this. It should go to A2 so that everything fits properly. Fine. I have life expectancy data in a different tab and GDP data in another tab. Now, save your work because you have done quite an important amount of work. Please save your work. Okay, so what does the question ask from me? So for GDP data, produce a line graph for Venezuela, Turkey, Syria, Egypt, Netherlands, Belgium, and Sweden. So let's go to GDP data. So for each graph, do them in a different tab. So let's insert a sheet near GDP data, and let's call this line graph GDP. So how do I do a line graph for Venezuela, Turkey, Syria, Egypt, Netherlands, and Belgium? So I am going to go to GDP data. Let's look here. So I'm going to find Venezuela. It's here. Now, look, I'm selecting the entire row of Venezuela. I'm not selecting this. When I click on the number here, it selects the entire row. Even before doing this, even before doing line graph, the first thing I should copy should be the first row, because I'm going to need this. I'm going to copy this. I'm going to paste it into the first row of line graph because I'm going to use this. Then I'm going to go select the entire row of Venezuela. Now, on Macs and PCs, this is a different button. But when you hold down either Control key or Alt key or Command key, it allows you to select multiple rows at the same time. So right now I'm holding the Command key on my computer. On your computer, it's going to be a different button. But here, if I hold down the Control button and select Venezuela, Turkey, where is Syria, Syrian Arab Republic, where is Egypt? Let's go find Egypt. Egypt is here. I'm selecting this, holding the Control button on my computer. On your computer, it's going to be a different one. Netherlands, let's find Netherlands. Netherlands, Belgium, and Sweden. So Belgium should be here. Sweden should be somewhere down. Okay. So I have selected multiple rows. If you can't find this button, don't worry. You can just do it manually, one by one. But I have selected multiple rows. I'm going to copy them. I am going to go to line graph GDP, and I am going to paste from A2. Nice. So I have a new sheet that has country names, country codes, cities. So from this point onwards, I do not need the country code, series name, and series code. So I'm going to just delete these 3 rows so that I only have country name and years. So it goes all the way to 2022. Now you're going to notice that some values do not exist. For example, 2022 years do not exist as well. So I'm going to just delete this as well. So the last year is 2021. But I also have these 2 dots, which indicate missing values. So when I try to do a visualization, it's going to give me an error. So I need to find and replace them. So in your own computer, this is probably in a different place. Please find where the find and replace section is. So here on my computer, the replace function is under edit. But if you're using a PC, it's probably in a different place. You need find and replace function. Now find what? I need these 2 dots. So we need dot, dot, and we need to replace with nothing, emptiness. We are deleting these 2 dots. So when I say replace all, it is going to delete all of those 2 dots. All done, we made 13 replacements. It means that there were 13 2-dot values. And now I have successfully removed them. Now, I am going to select these values. I'm going to go to Insert. Let's see if recommended charts give this to me. Yes, so on the recommended charts, there is a line graph which gives me this. Now, the problem that I have is the years section is not represented properly. So I am right-clicking on this graph and I need the select data option. Again, on your computer, this may be somewhere else. Just, it might be in a different place. It's not a problem. We just need this window. Now, how do I add years instead of numbers here? Because instead of 1, 2, 3, 4, 5, I need years, 1960, 1961. That is going to be determined by horizontal category axis labels, because this is the horizontal axis, the x-axis. I am going to select this by selecting this first row, 1960 all the way up to 2022. So now I have horizontal category axis labels, and when I click on OK, it's going to include this as years. So let's write an accurate chart title. This would be line graph for GDP per capita for 1, 2, 3, 4, 5, 6, 4, 7 countries. So this is the title. And if you want, you can change the visualization. It's not necessary. If you want, you can change, the color codes. This is not very meaningful. This is also not very meaningful. So maybe something like this. And this is also not very clear. Let's see. So here, what do I observe? Now, I see that beginning with 1960, Sweden, Netherlands, which one is this? Belgium. So these countries, these 3 countries used to be very close to the values of Turkey, Syrian Arab Republic, and Venezuela. And this is Egypt. But beginning with late 1960s, they have a significant increase in their GDP per capita. These 3 countries grow richer. So maybe here I can write an explanation. I can write something perhaps along the lines of description, because it's always important to interpret these graphs. Countries in our sample have close GDP per capita values until early 1970s. Later, Sweden, Belgium, and Netherlands witness a significant increase in their values. The first peak takes place in 1978, 1979. It takes place in 1979. Another peak happens in 1991. And then another peak happens somewhere between 2009, 2011. And the third peak in 2009, 2011. And the highest GDP per capita is for Sweden for 2022. The most recent values indicate that Sweden has the highest GDP per capita, whereas in the sample, the Syrian Arab Republic or Syria has the lowest because they have war, whereas Syria has the lowest. So this kind of description is always valuable, and I'm going to ask you to interpret this graph in the final project as well. Save your work. Again, it's very, very important. Now, the first part of the question is done. What is the second part? Descriptive statistics and a histogram for 2020 values. So let me insert another sheet here. Let me rename this. Descriptive statistics and histogram for GDP. Being clean and specific with your data analysis is always important because you know what you're doing right now, but a week later, you will not remember any of this. So it's very important to be clear with your descriptions. Now, again, what does the question ask? Descriptive statistics and histogram for 2020 values. I'm going back to GDP data. Now, for 2020 values, I only need the country name. I'm going to copy this and paste this here. Then I'm going to go and find 2020 values, which is here. Copy and paste. Again, I'm doing this fast, but you can slow this down and watch this again at any time you want. Here, I also have these 2 dots missing values. So let's do find and replace again. Find what, 2 dots, replace with what, nothing. So I'm going to find 2 dots and replace them with nothing. Replace all. We have made 13 replacements. Very good. Now, I need to produce descriptive statistics. So I need the data analysis option. Again, this can look a little bit different on your own computer. It can be in a different place. It doesn't matter. We did this plenty of times in class. You just need your data analysis section. So I'm going to click on this. I need to find descriptive statistics. So first thing it wants is an input range. So I'm selecting my input is on column B. So this is grouped by columns, not as rows. My values are in columns, and I have a label in the first row, which indicates that it belongs to 2020 values. Output range, just something close by, something like here, into which my descriptive statistics table can be produced. And I want summary statistics in this part. So I am clicking on OK, and I have summary statistics. So mean values are as such. So now I can just select these. I will go home, and I am going to describe them as number. So the mean GDP per capita is $17,000 for countries. So the global mean is $17,000. But when you adjust this to the number of countries, it's basically $6,000 per year. So it's somewhere around $550 per month, which is very, very low. The world is poor. So the mean, let's say description, the mean values for GDP per capita is 17,053 US dollars, whereas the median is 6,034 US dollars. Standard error, meaning basically how much lower and how much higher are the countries that exist in the 95% representativeness exist here. And standard error is 1,803 US dollars. Kurtosis. Now, as you remember, I already gave you a cheat sheet on the LMS on how to interpret kurtosis and skewness values and sample variance and standard deviation. So kurtosis indicates that at 13.3, this is heavily leaning towards the left. So it is kind of very pointy. It is kurtosis indicates that it's actually this is heavily pointed, which means that there is a high peak. And skewness indicates that the values lean towards the left. Range minimum, so the poorest country's yearly income is $216, extremely poor. Maximum, the richest country, probably Macau or Luxembourg or San Marino. Their values are very high, $182,000. Now, let's look at the histogram values and see the actual distribution. I am going to select the entire column B, and I'm going to insert a histogram here. Yes, so these values are high values, meaning rich countries. These values are low values, meaning poor countries. So as you can see, the majority of the world is quite poor. So I can right-click on this and format data series. This can also exist in a different part on your Excel. That's not a problem. You need to adjust the number of bins. Bins are these columns here. So when I increase the number of bins to reflect more countries, we notice that the majority of the countries are low income, and we see that from the point, there's a cutoff point here, and the cutoff point is right below $70,000. Majority of the countries are low income. The cutoff point at $70,000 is important because the majority of the countries are below that threshold. So the world is unequal. There are a very small number of rich countries. There are a very large number of poor countries. And this, when we say kurtosis, this is the peak that we're talking about. And skewness it's leaning towards the left. And that's basically how we interpret this. Save your work again very frequently. Pi and hierarchy graphs for 2010 values. Okay, another sheet needs to be inserted here. It needs to be renamed pi and hierarchy for GDP data. So to be able to produce a pi and hierarchy graph, I can just use the descriptive statistics values. I can just copy these values and I can just paste them here. And in order to do a pie graph, I need the maximum values. And in order to do that very easily, I can just format this as a table. Oh, let's pick a different color here. Where is the data for your table? Let's choose values. Let's not choose empty cells. Let's start with Zimbabwe, go all the way up. My table has headers because first row is country name, the second row is 2020. Wait, so I need 2010 values. Sorry, I can't do this for 2020. So I'm going to delete 2020 values. I'm going to go back to GDP data. I am going to take 2010 values. I'm going to copy 2010. I am going to go to pi and hierarchy graph, and I'm going to paste them here. I need to delete these two dots here as well. So I need to go find and replace all. We made 8 replacements. Good. So now I have to do this again. Format as table. Let's do this. Yes, you need from Zimbabwe, Zambia, all the way up to Afghanistan, and your table has headers. You click OK. And now let's order these in a descending fashion. Now, these are the richest countries in the world in terms of GDP per capita. Countries in which an individual is the richest. Monaco is the richest country in the world in terms of how wealthy the average person is. Liechtenstein is the world's second most wealthy country in terms of GDP per capita. Luxembourg, Bermuda, Norway, Cayman Islands, Switzerland, Qatar, Isle of Man, San Marino. These are very low population countries. So these are very low population countries, and some of the world's richest people live in those countries. So they are quite significant when it comes to GDP per capita. So let's select perhaps the first 20 countries, and let's insert a pie graph here. So these are relatively identical to one another. So when you put it in these terms, it doesn't give you a very good visualization. Maybe change this. So 11% of the top 20 GDP per capita. So we can say that top GDP per capita countries. In Monaco, Liechtenstein, you can change the color code as well, maybe to reflect, highest GDP per capita to lowest GDP per capita. Let's write some description here. Monaco, Liechtenstein, and Luxembourg are the top 3 highest GDP per capita countries in the world. There's not much to say, maybe with the exception of 1, 2, 3, 4, 5, 6, 7. Only 7 countries make up more than 50% of the top GDP per capita values in our 90-country sample. What does the question ask from me? Also, a hierarchy graph. So for hierarchy graph, maybe let's pick the first 50. And my hierarchy graphs are here, which is also called a tree map. Let's make this bigger. You can change the layout from here to make this perhaps more easier to check. Chart title, top 50 GDP per capita countries. Okay, so I have a bar graph, I have a tree graph or a hierarchy graph. This is also called a hierarchy graph. But we notice that Monaco, Liechtenstein, Luxembourg, Bermuda, Norway, Isle of Man, Qatar, Switzerland, Cayman Islands. These are some of the highest GDP per capita countries. Fine. What else? So, okay, for GDP per capita, this is what is being required. Now, I need to do similar things for life expectancy data. Line graph, descriptive statistics, and a simple bar graph for 2022 values. Now, let's go to life expectancy. Let's save this work again. It's very, very important. So let's create a new sheet. This is going to be line graph for life expectancy. And in order to produce a line graph, I need years. So I'm going to copy rows, the first row, paste it here into the first row of this new empty sheet. And which countries does the question ask me to produce? So produce a line graph for Turkey. I'm holding down the control button. You can select multiple countries from your end. Turkey, Iran, Iraq. Let's go to Iran, Iraq, Greece, Japan, China, Greece, Japan, China, Switzerland, and Brazil. Switzerland and Brazil. I am copying them. And I am going to paste them beginning with A2. Country names, country codes, series name, series code. I no longer need these, so I am deleting them. And I am going to select these, go to insert. I need a line graph. So as you notice, the values have a dip here. It's because the latest 2022 values do not exist. So I have to delete 2022 values because no country has those values. Now I'm selecting these again. Now I'm choosing insert line graph. Again, instead of these numbers, I want years to be represented. So I'm going to right click on this. Again, this can be in a different part on your Excel. It's okay. It's not a big deal. You need select data and you need to define horizontal category access labels. And my labels are in the first row. So I'm selecting the entire row. Then I'm clicking OK. Now I have these for all years. Let me see what would be a good representation for this data. Quick layout. Let's perhaps change the layout, change colors as well. Now I think, yeah, this is better. So in terms of description, let's see. So here's a country that has a very low life expectancy, and that's China. So up until 1963, China has a very low life expectancy, and also Iran as well. But China is actually much, much worse. Up until 1960, China has a low life expectancy. And after mid-1960s, Chinese life expectancy increased at the same rate with the rest of the sample. Here, Iraq has a high life expectancy up until 1970s. Until mid-1970s, Iraq has a high life expectancy. Which declines by 1980s and onwards. Top 3 high life expectancy countries are Switzerland, Greece, and Japan. Japan, Greece, and Switzerland have the top 3 life expectancy. Most countries see similar increases in their life expectancy. Because when you look from 1961 to 2021, the rate with which Greece, Japan, Switzerland, China, Turkey, they all increase relatively similar. Most countries see similar increase in their life expectancy, except Iraq, because it's is suffering from a civil war and external intervention, which is why it has a low life expectancy. All right, so let's continue from our line graph here. So from this point onwards, I'll go a little bit fast. You can just stop whenever you need to, if you can't keep up. So let's look at what the question is asking from me. So line graph I produced the descriptive statistics and histogram for 2019 values. So let's open up a new sheet, rename this as histogram and descriptive statistics for life expectancy. So which year? It's for 2019 values. Stop sharing, start again. Okay, so in life expectancy data, I'm selecting it all, copying and pasting my countries. It's 2019 values. I have to go select 2019 values, copy and paste. We have to get rid of these two dots. So I have to go find and replace these two dots with nothing. Made replacements. So to produce descriptive statistics, I have to go to data, click on data analysis and produce descriptive statistics. Select my input for descriptive statistics, which is my column B. It's presented in columns. There are labels in the first row. The output range is here. It's already selected. Summary statistics is clicked. Now I'm clicking OK. So here, let's write the description. The mean life expectancy in the world is 72.9 years old, whereas the median is 74.04. The most frequent life expectancy in our data is 71.8. Now, kurtosis is negative, which means that the general trend of the curve of the histogram is curved towards the bottom, whereas skewness is also negative, meaning that the clustering is slightly towards the right-hand side. So if the skewness was closer to 1, it would be significantly towards the right. If kurtosis was closer to -1, it would be very sloped, but it's curved towards the bottom slightly. So let's look at the visual representation. So before that, the lowest life expectancy is 52.9, whereas the highest is 85.18. So we can also produce a histogram to be able to look at this better. In order to do that, I'm going to select the entire row B, go to Insert, and insert a histogram. Just like we see in the descriptive statistics, it's slightly curved. The trend line is slightly curved toward the bottom. If you want to see this more clearly, you can format the data series. This can be, format data series can be in a different part of your computer, as long as you adjust the number of bins to a number that gives you a meaningful representation. So let's say 20. So this gives us what exactly the above tells. So the majority of the countries are actually in between 73 to 74 margin. So the statistical average of this graph is around here. Kurtosis is negative because it is curving towards the bottom. And then it is skewed negatively, which means it's clustered towards the right. So this gives me basically two clusters. Let's write a description. The data is clustered in two areas. Low life expectancy group, which is around 59 to 70 years of age, and a high life expectancy group, which is around 70 to 85 years of age. The most populated cluster is this one. There are 22 countries that have a life expectancy between 70 to 72. Is the 70 to 72 years old age cluster, which contains 22 countries. Always write the chart title, histogram of life expectancy values. Okay, save your work very frequently. Then a simple bar graph for 2012 values. Let's create a new sheet, rename this bar graph life expectancy. So we go to life expectancy data. I select my countries, copy, and paste it here. And then I have to take their 2012 values, which is here in column BE 2012 values. I have to get rid of these two dots, so I have to go find and replace again. Find two dots, replace it with nothing. We have 7 replacements. Now, in order to create a bar graph, I need to convert this into a table. Let's select my values to convert into table all the way to Zimbabwe. My table has headers because look, country name and year are here. So in order to find the highest life expectancy countries in this list alone, we just do a descending run. We just sort them. And Hong Kong, Gibraltar, Macau, Japan, Iceland, Switzerland, these are the highest life expectancy countries. Let's maybe select the top 30 and insert a bar graph for this. So this y-axis is life expectancy in age, and these are the countries on the x-axis. You can switch row to column as well. So you can change the colors if you want to perhaps reflect more. So the chart title is bar graph of top life expectancy countries. So the description is that Hong Kong, Gibraltar, and Macau enjoy the highest life expectancy. I can't really see these figures very well, so I'm going to change chart design in a way that I can see them much clearly. What else is there to say? There are no dramatic changes or sudden drops in life expectancy, basically declines in a very linear fashion. So we produced a simple bar graph. Now produce a correlation graph for GDP per capita and life expectancy. And the plots graph. Okay. We have never done plot graph before. This is the first time we are going to do this. So insert a new sheet, correlation, and plot graph. So what do we need the plot graph for? A correlation graph for GDP per capita and life expectancy. So this is for the latest values. I am going to go to my GDP data, copy my countries, paste them here. And then I am going to get their most recent GDP data, which is 2021. I'm copying 2021 figures. I'm pasting it here, 2021 GDP per capita values. And I'm going to do the same thing for life expectancy data. We have to go and find their latest value, which is again 2021. To be able to compare two things in a correlation, they have to belong to the same year, or they have to represent the same dynamics. So we have 2021 GDP per capita, 2021 life expectancy. We have to get rid of these two dots again. Find and replace those dots. Now, for us to be able to produce a correlation graph, both values have to exist for countries. So here, for example, we have for American Samoa, we have GDP per capita figures, but no life expectancy figure. For Andorra, we have GDP per capita figure, but no life expectancy figure. So to be able to produce a correct correlation graph, we have to get rid of these countries that contain missing values. So I'm going to delete these two rows. I am going to shift the cells up so that Angola comes right after Algeria. Same thing for British Virgin Islands. I'm holding Alt or Control, depending on which computer you're using. I'm selecting multiple rows right now to make it faster. Cayman Islands, Channel Islands, Cuba, it doesn't have life expectancy values, Curacao, Eritrea, we have Gibraltar, Greenland, missing values, Isle of Man, missing values, North Korea, Kuwait, missing values, Liechtenstein, missing values, Monaco has missing values for life expectancy, Northern Marinara Islands, Palau, San Marino, Saint Martin, South Sudan, Saint Martin French part, Syrian Arab Republic, Turkmenistan, Venezuela, Virgin Islands, Yemen. So I'm right-clicking and deleting these rows so that, as you can see, I no longer have any missing values. I have GDP per capita and life expectancy data for all countries. Now I need to produce a correlation graph. My input range are these two values. I need to select the values that contain numbers. They are represented in columns. We have labels in the first row. The output range is here. Everything is ready. Now I click on OK. So this is my correlation table. It shows me that at 0.68, this is a moderately strong correlation. Correlation is positive and moderately strong at 0.68. This means that GDP per capita and life expectancy are moderately correlated, which means that as GDP per capita increases, life expectancy also tends to increase to a certain point. Now, to be able to visualize this correlation graph, we need to insert a new type of graphic that we never did before, and that is called the scatter graph, XY scatter or scatter plot. So we select these two variables, GDP per capita and life expectancy, click on this. And we have to select this scatter plot. Now, every single dot here is a country. So every single dot represents a value between GDP per capita and life expectancy. The y-axis shows you life expectancy. The x-axis shows you GDP per capita. Now, we see that, yes, from low income up until $20,000 GDP per capita, life expectancy increases quite a lot. But after $2,000 a year, life expectancy doesn't really increase that much. There is not that much difference between having $20,000 a year versus $140,000 a year, and it basically gives you relatively the same life expectancy. So description: GDP per capita and life expectancy are correlated, but only until the $20,000 threshold, after which additional increases in GDP per capita do not increase life expectancy significantly. So, does being rich make a country live longer on average? To a certain extent. I mean, there is a correlation, of course. 0.68 is a good correlation, but the relationship is not linear, meaning it is only valid to a certain point up until this $20,000 mark. It does increase life expectancy all the way from 50 up until 80. But after this point onwards, additional increases in wealth doesn't really correlate significantly with life expectancy. Save our work. Now, produce a world map for each variable for 2015 values. We do the map the last because it's going to slow down your computer. To be able to produce maps, we need country name, which year does it want country? 2015 values. Okay, so we go to GDP data, find 2015 values, which is at BH column. I'm copying them. I'm pasting them. 2020 2015 GDP per capita values. And we have to do the same thing, 2015 for life expectancy data. We have to take the BH column and paste it here and write life expectancy. We still have these two dots, so we have to get rid of those missing values. Replace all. Now, let's produce the first map for GDP per capita values. We go to maps, we produce a map. Maybe make this a little bit more visible and interesting. So my computer started to get slow now. That's okay, as long as you save it very frequently. Doesn't really matter that much. We have to add a chart title, world map showing GDP per capita. Let's write description. Western developed countries have higher GDP per capita values in 2015, because as you can see, it's clustered on the United States, Canada, Norway, Denmark, Finland, European countries, a little bit Saudi Arabia, and Australia. Generally, South American and Sub-Saharan African countries tend to have a lower GDP per capita. Save this again, save it very frequently. It's very important that you save these, because once maps start to come into play, it's going to slow down your computer. That's why we're doing them last. Then the second map is going to be for column A, countries, and I'm holding the control key right now. Find your multiple selection key on your computer, and I'm selecting life expectancy. And I'm going to insert, again, produce a map. Make it bigger, change the colors accordingly so that it fits with the above style. When my computer freezes, I just be patient, I just wait. Because the reason why it's getting slow is that to be able to produce these maps, Excel is connecting to Bing, a search engine, and it is getting data live from the Bing engine. So let's add chart title, world map showing life expectancy. Now, description. Life expectancy tends to be higher in some high GDP per capita countries, such as Canada, Saudi Arabia, and EU countries. Life expectancy tends to be lower in Sub-Saharan African countries. Save your work. Okay, so this is how you do a question like this. Do countries with a high GDP per capita also have high life expectancy? Please produce a data analysis for this question using World Development Indicators. We went to World Bank dataset, we downloaded GDP per capita and life expectancy data. We parsed it on Excel. Then we produced a line graph for a select number of countries. We then produced a descriptive statistics and a histogram for GDP per capita. Then we produced a bar, produced a pie and hierarchy graph. Then we parsed and formatted life expectancy data. We produced a line graph on selected countries. Then we produced a histogram and descriptive statistics and interpreted them. We produced a simple bar graph and described them. Then we did a correlation table and then a scatter plot, a plot graph. And then we produced maps out of this. And then when you're done, you simply save this and upload it on the LMS. Please don't send these as emails, just upload them on the LMS. So how do you study for the final project? Try this protocol with different World Development Index variables, because in the final project, there are going to be different variables that you are going to do. This is just an example. I'm not going to ask exactly the same thing. There will be different variables. So the more variables you work with, the better you will get in doing all of this. Also try this with two variables from SIPRI military expenditure dataset, which we did a couple of weeks ago, Stockholm International Peace Research Institute military expenditure data. Pull two variables and do these exercises for military expenditure data, and then try this for two variables from United Nations Food and Agriculture Organization FAO-STAT database. The more you work with these data sets, the more you produce, the more you clean, the better it's going to be for you. So that's it for today. Good luck in your studies. On Thursday, Azade, our course assistant, and I will be holding a Zoom office hour in case you are having difficulty with something or you need help from us. Thursday is going to be the time where you'll be able to ask us any questions that you may have. But that's it for today. Good luck with the final project and take care, please.